Imagine this. Put your hand on the table in front of you. You can feel its surface. You can push against it. You can feel its weight and its texture. But here's something strange. At the atomic level, you have never actually touched that table. In fact, you've never truly touched anything in your entire life. That might sound impossible. After all, if your hand isn't actually touching the table, what are you feeling? The answer takes us deep into the strange world of atoms, electrons, and quantum physics. In everyday life, we imagine touching as two objects physically coming into contact. Your hand touches a wall, a glass touches a table, your feet touch the ground. But matter isn't really made of tiny solid objects packed together like Lego bricks. Everything around you, including your own body, is made of atoms. And when we look inside those atoms, things become much stranger than they appear. Because an atom isn't a tiny solid ball. It has an incredibly small nucleus surrounded by electrons described by quantum mechanics. And this changes what we mean by touch. Every atom has a tiny nucleus at its center, containing protons and neutrons. Around that nucleus are electrons. But here's the important part. Electrons aren't simply little balls orbiting the nucleus like planets around the sun. In quantum mechanics, they're described by probability distributions, often represented as an electron cloud, and the scale is almost impossible to imagine. The nucleus is incredibly small compared with the overall size of an atom. So when you press your hand against a table, you're not really pushing two collections of tiny solid balls against each other. You're bringing enormous numbers of atoms close together. And that's when something very important happens. If atoms are mostly not solid in the way we imagine them, why doesn't your hand simply pass through the table? Because the particles making up your hand and the particles making up the table interact with each other. One of the most important interactions here is the electromagnetic force. Electrons carry negative electric charge, and when the electron distributions in the atoms of your hand get extremely close to those in the atoms of the table, their quantum and electromagnetic interactions strongly resist that compression. There is also another important piece of quantum mechanics, the Pauli exclusion principle. Very roughly, it prevents identical fermions, such as electrons, from occupying the same quantum state. Together, these effects are a major part of why ordinary matter doesn't simply collapse into itself. So when you push your hand against a table, the table pushes back. You experience that resistance as pressure, and your brain interprets that interaction as touch. Does that mean touching isn't real? Not at all. The table is real, your hand is real, and the force you feel is completely real. What's misleading is our everyday mental picture of what touching means. At the microscopic level, what you're experiencing isn't simply two solid surfaces physically merging together. You're experiencing the interactions between the particles making up those surfaces. So when you feel a table beneath your hand, you're actually feeling the forces between your matter and its matter. You're not feeling atoms touching in the way you imagine. This is what makes the microscopic world so strange. A wall feels completely solid. You can't simply walk through it, but the solidity you experience isn't because atoms are tiny, indestructible balls packed perfectly together. It's an emergent property of countless particles interacting according to the laws of physics. Billions upon billions of atoms interact simultaneously. Their electromagnetic interactions, quantum mechanical behavior, and the structure of matter create the solid world that we experience. And somehow, from this incredibly strange microscopic reality, we get the world that feels completely normal to us. And this isn't just happening every time you sit on a chair, every time you hold your phone, every time you open a door, every time your feet touch the ground. The same fundamental physics is happening. Your senses don't directly show you electrons, quantum states, or electromagnetic fields. Instead, your brain takes the information produced by these interactions and turns it into the familiar experience of touch. The solid world we experience is, in a sense, an interpretation of something much stranger underneath. We spend our entire lives surrounded by solid objects, walls, tables, trees, our own bodies, and because they feel solid, we naturally assume that reality is exactly what our senses tell us it is. But zoom in far enough, and that familiar world begins to disappear. What looks like solid matter is built from atoms. Atoms are governed by quantum mechanics, and what we experience as touch is ultimately the result of invisible interactions between particles. So the next time you place your hand against a wall, remember this: you aren't experiencing the universe exactly as it is. You're experiencing the version of it your brain can perceive, and perhaps that's one of the strangest things about reality. The world we've known our entire lives may be completely different from the world that actually exists beneath it.